Okay, welcome back. Today we got a original Xbox with no power, won't turn on. I've taken out the ROM drive, I've taken out the hard drive, and I'm left with the motherboard and the power supply. Plugged into power, okay, press the power button, nothing. So it's usually the power supply. So you can get new power supplies fairly cheap. But I like to repair the ones I have, so we'll have a look at this and I'll show you the process I use to trace a fault in switch mode power supplies. Okay, so welcome back. We've got this switch mode power supply here and we're going to see if we can repair or find the problems with it. And without further ado, let's get stuck into it. Now be careful because it is 240 volt power and you can kill yourself. So I'm a fully qualified radio tradesman, so I'm qualified to touch this 240 volt power on these old devices, but you must be careful. And you'll notice the procedure that I use to fix these. I'm not sticking my hands over everything, and I'm just very cautious as to how I go about it. So how do we fix this? Where's the problem? What do we do? So without further ado, we'll get started. Now, just got to get my meter in range. Okay, so the very first thing I'm going to do, sometimes you can do a visual inspection and just see if there's anything burnt on the board. You've got a fuse. There is a fuse, little fuse up here. Okay, that little round black device says a fuse. But I like to put 240 volt power on it straight away. Now we've already ascertained that there's no 3 volt standby voltage. Okay, so there is no 3 volt standby voltage on this orange wire here. So basically you've got two parts of your power supply. You've got this primary side and your secondary side. This side here, of this primary side, this side here, that produces all your voltages for your 3 volt rail. Once that 3 volt rail fires up, it relies on the motherboard to then feed a voltage back through these opto couplers here. Alright, the 2 opto couplers. Okay, through these opto couplers, and then gets this chopper transistor fired up and gets your flows through to the secondary side of the transformer here to the output and gets your main volt rail here. Alright, this main coil here has DC volts, and you have your 12 volt rail all fires up there. Okay. So haven't got any 3 volt rail, so we're concentrating on this side of the circuitry. Okay, so what I'm going to do, I'm going to put 240 volt power directly onto it. So now there is 240 on there, you can get killed, so you must be very careful. So you can't, yes, you can go through and try and check every component, but you'll be there for a month of Sundays. Okay, it's just you might fluke it, you might find it, but you could be there for a month of Sundays. So with voltages, you can actually track your problems down a lot quicker. Okay, so what I'm going to do, so I've got 240 volt power on this thing, and I'm just going to be careful I'm not touching anything. You see these cautionary arrows on here? They're not there for no reason. So the very first thing I'm going to do, I'm not going to check the fuses and all this front end. I'm going straight to this main filter capacitor, which is a 100 microfarad 400 volt cap. You should have about 300 odd volts on that DC. Okay. That's after the signal, the AC's come through, it's gone through this rectifier here, this little bridge rectifier here. Okay, AC comes through this bridge rectifier here. Alright, gets converted to DC, and this capacitor filters the DC out, okay? Okay. Now, just to adjust that focus. Okay, so now, remembering that there's 240 volt power in here, and we can see our filter capacitor. So what I'm going to do, I'm going to measure across that filter capacitor on the DC volt range, okay? So, I'll move across here a little bit. Okay. So, we've got our DC capacitor. What have we got here? So, we've got 324 volts. 324. 324.4. Now, that's already told me that I've got 240 volt coming in. It tells me my fuse is okay. It tells me my bridge rectifier is okay. So, I've checked all those components already without actually physically measuring those components. Now, just remember that that capacitor is going to charge up. So once I disconnect my voltage, there's going to be voltage on that capacitor. It's going to give me a whack. So I'll show you shortly how I get around that. Okay, so we've got voltage on there. Now we know we haven't got any voltage on the 3 volt side of things. 0. Okay. The brown wire, the orange wire, we've got. Keep a bit in the camera way there. Okay. So we've got no voltage there. Okay. Okay. Have we got any voltage on the chopper transistor? That's your main chopper, right? So we have to find the earth point. So the earth point here is where the negative, that white arrow is negative. So we make sure our probes are the right way around the multimeter. So that's our negative. Now that main component, that's your negative. So I can stay from this side of the power supply on negative. Okay. And this main transistor here has voltage on it, but nothing across it. So that's its main source is coming into it. Now I don't expect any bias across here, because with a transistor to be biased it must have a roughly 0.6 of a volt across its base emitter, okay? Or across its gate and drain, okay? Depending if it's a FET transistor or what type of transistor it is. So it's basically 0.6, but that's not biased on anyway, because we know that 12 volt's not fired up, all right? So we're still back over this side of the circuitry. But there is voltage getting to that component there, so we're not too worried about that. Now this IC here, that one there is a jungle IC, okay? That one is a jungle IC, and that's your oscillator, it's your circuitry which actually turns this transistor on, okay? We're not worried about that at the moment. So back to this primary circuit of the 3 volt rail here. We've got 2 optocouplers there. So what we're going to do, there's the main transistor for the primary 3 volt circuit is this little one down in here. See him? So that one down there. Okay, that one, the little silver. That one there. So what we're going to do, we're going to work out where those points are, which is 1, 2, 3, 1, 2, 3, which is 1, 2, 3. 1, 2, 3, 1, 2, 3, which is 1, 2, 3. Okay, so we're going from our earth. hands off the board to that transistor. It must have a rail on it. And we've got nothing on the centre pin, alright, which is normally the collector. So there's nothing on there, nothing on there, nothing on there. So there's no voltage there. What could be wrong? So we need to trace from that centre pin back. Now, the supply voltage for that transistor comes through R901, okay, which is a little resistor down in here, which is, if I work out where those points are, which is here, okay. So I go from earth to this resistor here, I've got nothing, but on the other side of the resistor, I've got 299 volts. Well, it says 316 now, okay. So we've got 316 there, nothing there. So that resistor is open circuit. Now, resistors don't normally go open circuit for no reason. You've probably got a short. If I short out one side, if I have voltage on one side of the resistor and I short the other side out, that resistor is going to go open or going to go high. Resistors never go short circuit, okay? They either go open circuit or high. So that resistor is faulty. So I'm going to disconnect the 240 volt power. Now bearing in mind that the board is still charged up. I've taken the power off, but this is dangerous. I can get a zap off this board because this main filter capacitor is going to stay charged up. So how do I fix the problem? Well, what I do, I get a low value resistor. This one's a 3 watt, 3.3 ohm. You can use a you know, anything of low value, and I'm going to put it across the capacitor, and see that zap? So that's now discharged that capacitor. Now it's safe to touch, okay? So I'm going to whip out that resistor. Now the thing is, I've probably got a short on the output from that resistor, okay, which is running up to this transistor via this coil, okay. Now this little transistor here, which does the work for my 3 volt run, I'm going to measure it on ohms, and we've got 2k, 2000 ohms. 2.7, now that's too low. There's an issue there, okay? So I say that transistor is faulty, we're going to whip that transistor out, okay? And whip that resistor out. Okay, so we're going to whip that resistor out of there. Okay, now that resistor is a 22 ohm resistor, and it's ready to open, okay? Open, nutter, zilch. Nil, okay? Touch our probes together, okay? So that 22 ohm resistor is faulty, so we put that aside. How do I know it's 22 ohm? Because we've got a red and black band, okay? So 22 ohm. Now, that little other transistor, I'm just going to whip that other transistor out of there. Sometimes when you're desoldering, you can actually add solder to help the heat transfer process, okay? Okay, so that's our transistor out, which is Q901. Okay, and I'll just see what that is. It's a a 1N60B. Or IN60B. Double confirm that. No, it's a 1N60B. Alright. Which is an N-channel MOSFET, okay? Now we're going to measure that again. Okay. What's out of circuit? In case, sometimes you're going to get a short reads in circuit here, and you take the component out and it reads okay. If the component reads okay, the short is somewhere off that leg, okay, off that track. So we've got 3K and we've got 19 ohms, so that's too low. How do I know it's low? Well, 19 ohms too low. It should read K or read open, okay? So not knowing exactly what readings we should have, but that's definitely faulty. Okay, so I've got another Q901 here. Which I pulled out of another Xbox power supply, but they're just a standard FET. So I'm going to measure the new one and compare it to the old one. So nothing there, 3K there, nothing there, nothing there. So it's definitely reading okay. Okay, so this one is definitely reading 19 ohms, which is wrong. $19 ohms, okay? So we'll get rid of that. And we've got our 22 ohm resistor replacement. Now, it's all this transistor's also got a little diode across it. So I'm just going to check that diode. And it's 0.4 of an ohm, okay? So that diode, okay, back again, the phone was ringing. So this diode here, and it's ZD902, which is Zener, is shorted. So we're going to whip that off. Just going to whip that off out of there. Taking notice at the orientation of the diode, being a Zener, you got your anode and cathode. Right, and the cathode's going to ground, okay? So it's got a little line across here, so make sure the line is facing outwards. I'm just going to add a bit of heat either side and just pull that off like so. Okay. Now our Zener diode is out. Now our Zener diode is out. I'm just going to measure it. And it's shorted, so that's faulty. Okay, so now I'll just check what this diode is, and it's got 18 written on it. So I say it's an 18 volt Zener. Okay. So I've got another one out of another Xbox, which is an 18 volt Zener. We'll probably confirm that, show you how we can confirm that later. But this doesn't read a short, okay? So we've got to throw that Zener back in there, and these other two components back in there that we've found so far. Okay, so this is Zener, which is the right way around. Has that glue on there? Must be when they originally put it in there. But making sure of our orientation. That's our Zener back in there. Like so. Okay, then it's back here. Now I've got to get this resistor in. And it's right down underneath. This leg goes right down underneath this coil, so okay, that's in. Q901 going in. That's in. Looking good. Okay, so I'm going to So that's all back in. Okay, now I have noticed while pulling these components around that there's another resistor here that's actually completely burnt. Alright, it's actually burnt in there. Now that's R902, so I'm going to pull that one out. Because that is also a feed resistor to that part of your circuitry, alright? And see that? Burnt, okay. Okay, now we're going to measure it. And it's reading 47k, so I'll just go and check if I've got one of those. So once again, I've gone to my trusty old spare parts Xbox, and it's already got the colour bands already on here. So it's got 47 yellow, purple, orange, 47k. So just measure it to make sure it's all okay. So yeah, 46k. So now, so that resistor that burnt was all right, but it's been under stress. So it's got hot because it's had a load put across it. Not across it, we'll put on one side of it, and therefore it's going to get warm and eventually burn out. But it didn't burn out, just got hot and discoloured. So it has been under stress, and we'll replace that. It's caused by all these Q901 and Z and that diode. Zener. Let's write the Zener down. ZD902. Which is an 18 volt Zener. Okay, so I'll throw this resistor in. Okay, got that back in there. Turn my iron up a little bit, a bit light. Okay, so that's in. Now, have we got action in the station? Let's have a look. Okay, so what we're going to do, we're going to put power back on here. Put power back on this baby and see we've got action. And we've still got nothing. Alright. Still got nothing. Have we got a rail on this driver here? We know we've got 240 here. have we got power through this R901, which is a 22 ohm resistor? Yes, we have. Have we got voltage on this transistor? Yes, we have. Have we got bias across there, across these two outside leads? We've got 0 volts, so it's not turning on. Okay? So, there's still problems with this power supply. Now, what we normally do is go back further. Alright? What drives 901? Alright, because if you get the output transistor gone, say Q901's gone, what drives it? Alright, there's another transistor drives, one drives the other. So, and there is a transistor 902, which is back here, which goes all the way up to here. Have we got rail on 902? Have we got voltage on this rail? No. Nothing. Nothing. So I've got nothing on that transistor, okay? What I'm going to do, I'm going to take my power off. I'm going to discharge this capacitor. Okay. Now, normally that capacitor charges up because there's a fault in the circuitry. It's got nothing to drain the voltage away. If I had this going, if this was working, and I disconnected the power, that voltage there would dissipate and drain away. But it can't release its power, so there's definitely something going on here. So we're going to go back to the driver of here, which is 902, and we're going to measure on a meter. 902, 78 ohms, 80 ohms, 2 ohms. Problems. Is it this ZD601 here? No, that's just reading high, so that's okay. We're going to whip this Q902 out. And I'm going to measure this 902. Dead short, so 902's crook. Okay? So it's like a resistor. It went out. It went short because I had the output stage, right, was shorted. So Q901 went short, so it takes out this power resistor, supply resistor, and it takes out the driver. Okay, so this driver's crook. This is a MPS 222A. MPS, I'll just write that down. MPS 222A. 4 trues A, quad 2. Now, once again, I've got another transistor out of another Xbox. Okay, now this one here is a PN2222A, which is the same thing. Okay, so I'm just going to measure this one here. 2.5, nothing. So, yeah. Okay, I say it's a MOSFET, so we'll just straighten the legs up on him. And throw him back in there. Like so. Alright, now have we got action in the station? 240 volt power, DC volts. Sorry, I'll just zoom back out. Sorry about that. Okay, 240 volt power, DC volts, 3 volts. Okay, so we've got this Xbox One. We've put power. We're putting power back on it, and we've now got our now got our 3 volts standby voltage. Okay, and she's a goer. Alright, she's only flashing orange because there's no hard drive. So we've got power back, that's all fixed. All working. Yeah, so that's how I trace the fault through on a switch mode power supply in an Xbox One. So just remembering that there is 240 volt power, so you can kill yourself. So I am qualified to repair these. So it's purely for educational purposes. You can apply the same techniques to nearly any switch mode power supply. They're all basically the same setup, slight variations, but main stages are all the same. And so yeah, thank you for watching, and please subscribe and have a nice day. Thank you.